Hi everyone, this is Melody Rondeau and I'm going to be walking us through our lesson on base angles theorem, isosceles triangles, and this should be found on page 29 in your notebook, so you can check it out there. Write down your learning intention. I'm learning how to apply basic triangle theorems. Our success criteria today, I can explain the base angles theorem for isosceles triangles, and I can apply the base angles theorem for isosceles triangles to find missing values. Just a kind reminder, isosceles is the word we use to describe a triangle with two sides that are congruent. So let's take a look. All right, so we have the base angles theorem. Take a minute and write this down. If two sides in a triangle are congruent, so I'm going to come over here to my picture and I'm going to show two sides are congruent, this one and this one. Those are my congruent sides. And then we talked about the third side being not congruent, so I'm going to put two tick marks to show it's a different length. That other side actually has a special name. It's called the base side of the triangle, and we'll talk more about that in a minute. Let's go ahead back to our theorem here. So if two sides in a triangle are congruent, then the two angles opposite those sides are congruent. So opposite the side on the left would be this angle right over here, and opposite the side on the right would be this angle right over here. So these two angles have a special label in an isosceles triangle. These are called the base angles. They are the angles that connect a congruent side to that third or other side. So congruent side connected to the other side. Base angles. Then there is another angle in our triangle, this one at the top, which we're going to mark with two arc marks. That angle at the top has its own special name. It is called the vertex angle. And again, it's marked with two arc marks to show it is not congruent to those base angles. So it's another angle, but not congruent to the base angles. And then if you need more time, make sure to pause and fill in anything you might have missed. Here again, the theorem is if I have two congruent sides, then I have two congruent angles. It works in reverse as well, what we call the converse. We'll talk more about converses later. But basically, the reverse is true, called the converse. If I have two congruent angles, then I know I have two congruent sides. So let's get to it and practice. So find the value of x. Well, I see two congruent sides, which means I have two congruent angles. So therefore, x must be 43 degrees. Next problem. Find the measure of angle A, and then find the measure of angle B. Oh, it says and. Measure of angle A and B. So here I see two congruent sides. So the first thing I'm going to do is make sure I know which angles are the congruent angles. So is it A and B, B and C, C and A, C and B? You have a couple different sets there that it could be. So I would follow my congruent sides have to connect to the congruent angle. So those congruent sides connect to my congruent angle. So I have these two angles are the ones that must be congruent, which means angle B must be 67 degrees because it is a base angle. So I'm going to write that over here. Measure of angle B is 67 degrees. Sorry, that B kind of looks like a 13, so I'm going to fix that real quick. There we go. And then to find the measure of angle A, we should know something we learned earlier in the week called triangle sum theorem. We know that all the angles of a triangle add up to 180, and so to figure out that missing angle, I can do 67 plus 67. Since those happen to be the same, you could actually multiply it by 2, but I'm going to do plus. And I get, let's see, 4, carry the 1, looks like 134. And then again, triangle sum theorem says all the angles add up to 180. So I can take 180 and subtract the 134 degrees that I've already used up, and I have 46 left over. So my measure of angle A would be 46 degrees. Let's go forward. Example 3, this one, once again, I see two congruent sides, so I'm going to immediately start by marking congruent angles. So I'm going to find which ones are the congruent ones. Again, they have to be touching one of those congruent sides. So it's going to be this one and this one. So in this case, I don't know my congruent angles, but I do know that this one is called, the angle F is called X. So I'm going to call it angle E. I'm going to call it X also because I know they are the same. And if I do it that way, I can actually, so there are a couple ways I can do it if you kind of understand it on your own. There's like a quick math way to do it, and then there's also writing an equation. So I'm going to show you the quick math version really quickly, and then I'll show you the equation version. So the quick math version, both of them use the triangle sum theorem. We know all the angles add up to 180. So if I take 180 and I subtract the 48 degrees that I know, I do some math here, some borrowing, and I get, let's see, it looks like 132. So my two remaining angles have to total to 132 degrees. Since they have to also be the same, I can take that 132 and I can divide it in half or divide it by 2. I'm sorry, I don't know why I wrote it division that way. I mean, that is fine. You can do division that way. I'm going to do it the fraction version, 132 divided by 2. Pop that into a calculator and you should get 66. So that would be X equals 66 degrees. And again, this is just doing quick math. If you're not comfortable with that, or if you are, do it that way. But if you're not, you could build an equation like we did when we were learning triangle sum theorem that says basically I know X plus 48. So all three of the angles in my triangle have to add up to 180. Then I would combine like terms and I get, sorry, my pen stopped working for a quick second, hold on. Okay, so then I would get 2x plus 48 equals 180. And solving for x, I would subtract 48. So right there, we're doing the same math that we did in the first one. We subtracted 48. Here we subtract 48. I get 2x equals 180 minus 48, we already know is 132. And then to solve for x, we would divide both sides by 2, which we did in our quick math version as well. And here we get x equals 66. So either way you do it, you end up with the same answer. Let's go forward. Number 4, find the length of PQ. So this is using the base angles theorem, or the base theorem backwards. We know two congruent angles, so if we have two congruent angles, then we also must have two congruent sides, which means the length of PQ must be 11. For number 5, which unknown side of the triangle must also be 8 units long? Well, once again, I have two congruent angles, and so we want to be careful that we mark the congruent sides. So the congruent sides have to both be touching only one angle. So this touches one of the congruent angles and this does. So this side is 8, which means this side is 8. To answer our question though, which unknown side of the triangle must also be 8 units long? That would be TV, side or line segment, but when it's in a triangle we call it side, TV, or you could call it VT. I think that finishes our notes. You guys should have a practice assignment. Check Google Classroom, and I will see you guys back next time.